So, welcome to Visista Pharma School, where I'm going to talk about in this industrial pharmacy topic related to dissolution test. So, this dissolution test is one of the important tests which will tell you how the drug is bioavailable to the systemic circulation. So, this test is being carried out by a test apparatus known as a dissolution test apparatus, and it has many models. And we'll see how the dissolution apparatus basic components will look like, and we'll see what are the various models that are present in dissolution apparatus to meet the requirements of various dosage forms. Okay, let us take picture. So here, this dissolution test apparatus consists of a basket. This basket is made up of stainless steel, and you have a shaft. This basket is fixed to this shaft. This basket is fixed to this shaft, and this shaft is also made up of stainless steel. So the basket assembly will look like once if it is placed in the dissolution apparatus. This is the basket which is fixed to the shaft. The entire unit is placed in the dissolution jar. So in the dissolution jar, here you have a sampling port wherein you can able to withdraw samples at frequent intervals of time to find out the dissolution rate of the dosage form. And here you'll be taking a dissolution medium of 900 ml. So here the dissolution medium will vary depending upon the monograph, or the dissolution medium is being specifically mentioned for that particular drug. Generally 0.1 and HCl or any phosphate buffer of 9.8 or 7.2 will be given, and that particular pH buffer can be prepared, and all those things you can able to find out in the pharmacopoeia. Okay, so here you have to understand that in dissolution medium, the medium generally is 900 ml, whereas in the disintegration test, the disintegration medium is 1000 ml. Please be cautious about these two volumes. And here, if you see, this is another model 2. This is known as model 2, dissolution apparatus model 2, which consists of a stainless steel paddle. This is known as paddle. And if you see here, this is the dissolution jar, and this is another dissolution jar consisting of the dissolution medium. So these are various components of dissolution test apparatus. Now, coming to the types of apparatus. For example, let us say dissolution apparatus consists of apparatus 1, 2, 3, 4, 5, and 6. So apparatus 1 is known as rotating basket, which I have discussed just now. It is used for conventional tablets or sustained release or controlled release tablets or chewable tablets. Apparatus 2 is known as a rotating paddle type. This is how the apparatus 2 will look like. Just now in the earlier picture, I have shown this is the paddle 1. So this is the paddle 2. Whereas apparatus 1 is basket model, apparatus 2 is paddle model, and apparatus 3, this is the one which you see here. This is known as reciprocating cylinder, which is used for controlled release formulations. And the apparatus 4 is known as a flow through cell. This is how the apparatus 4 will look like, and this is used mostly for poorly soluble drugs, for powders, granules, microparticles, implants, etc. Okay, coming to apparatus 5, which is known as paddle over disc. Can you see here? This is the paddle, and the disc is placed over here. This is used mostly for transdermal formulations. This is an apparatus 5. Okay, apparatus 6 is known as a cylinder model, which is used for transdermal formulation. This is how the apparatus 6 will look like. If you see, these are the 6 types of dissolution models which are used for finding out the rate of drug release at different intervals of time for that particular dosage form. The most widely used dissolution models are apparatus 1 and 2. But from 3 onwards, they are used for specific purpose. Okay, so these are the different types of dissolution models, and in every case, you can able to use the dissolution apparatus for finding out the standard graph. If you wanted to construct a standard graph, you can make different concentrations. For example, here 0.051 constant, 0.1, like that, 0.2 molar, 0.25 molar. So you can make different concentrations, and you can able to find the absorbance, and you can draw a graph, and it should be a linear graph. This is known as a standard graph. And by using the standard graph, you can able to calculate the unknown samples from the concentrations which are obtained from the samples. So when you determine the samples, and if you get unknown samples concentration, where you'll get the concentration, but you don't get the absorbance, or if you get the absorbance, the concentrations can be predicted. So how you can able to predict? For example, let us say if you're having an unknown concentration, you don't know the concentration, so you get the absorbance. So you get the value here and extrapolate it to this linear graph. And when it strikes over here to the intersection point, drop a perpendicular to x-axis. That is the concentration of the absorbance, what it is being known. For similarly, if you know the concentration and if you don't know the absorbance, so you take, let us say, 0.2 concentration, extrapolate to this line, and to the at this intersection point, drop a perpendicular to y-axis. Then that is the concentration for that particular, that is the absorbance for that particular concentration. So by using this standard graph, you can able to determine the unknown concentrations or absorbances of samples by using this standard graph. So you can able to plot a standard graph by using dissolution test apparatus, as well as you can able to find out the dissolution at different time intervals. So at 5 minutes, how is the dissolution rate? At 10 minutes, how much is the drug that is released? At 15 minutes, 20 minutes, 30 minutes. So in the monograph, what happens, what the monograph says is, for many of the dosage forms, like solid dosage form especially, it will say that within 30 minutes, more than 90% of the drug must be released. Or they'll say within 30 minutes, a drug release of more than 70% must be obtained. Or they will specifically mention how much should be the drug release at that particular time. So that is how the condition is given in order to have a dissolution test passing that for that particular monograph. Similarly, you can also find out the time of dissolution at 50%, time at 50%, and time of 90%. T90 and T50 can also be determined. That means the amount of drug at 50% and 90% can be determined. So likewise, what happens is this dissolution test will give you the rate of drug release at a particular specific time. Suppose if you are using the same test for controlled release. So what happens is controlled release or sustained release, that means it will have an initial loading dose. Once it is in the therapeutic window, the drug will be continued for a prolonged period of time. So the drug will be releasing continuously for more than 6 hours, 8 hours, 12 hours, 24 hours, or even more than that. So at 12 hours, how is the rate of drug release? At 15 hours, at 20 hours, at 24 hours, how much is the rate of drug release can be determined by using this dissolution apparatus. So dissolution plays a very important role in predicting the rate of drug release at a given point of time. So here the dissolution, if at all, if it has to pass, first disintegration has to be passed. So once the core tablet is administered orally, the tablet which is being administered first, it should disintegrate. That means it should, the core tablet should split into granules. That is the disintegration stage. Once these granules are subjected for a prolonged period of time in the stomach, so thereby what happens, these granules will further split into smaller particles, which results in dissolution, where the dissolution is being determined by this test. So the disintegration and dissolution should go one after the other. Then only you can able to get a good tablet with good bioavailability. So this is all about the dissolution test. And thank you for giving me this opportunity. And we'll see some more tablets in the subsequent classes.